Hey, my name is Wojtek, as Nick said. I thought that running SQLite in production will be a hot take, and I know that you're here for the hot takes, but on the yesterday's after party, I learned that that may not be as controversial anymore. So I'll try to up it up a little, and I'll try to convince you that for a lot of medium-sized apps, a lot of medium-sized apps would be even better off if they migrated from Postgres to SQLite. So let me start by explaining why we went into that road. I'm a tech lead at a small startup. We have our development teams is 8 people in total. Only 3 of us are backend developers. So we don't have that much velocity. Our race application at the moment of the migration had around 80,000 lines of code and twice as many lines of tests. So it wasn't enormous, but it wasn't also just a hello world app. So we are a small startup. We have very tight budgets, tight deadlines. So, well, there is no time for optimizations. And we don't have a separate dedicated DevOps team. I mean, everyone needs to wear a lot of hats. Everyone needs to do everything. So I was inspired by Steven Markheim's presentation on Wrocław RB in 2024. If you haven't seen it, I really recommend it. It's great. But wasn't fully convinced just yet. Then Race added support for, Race support for SQLite improved a lot. Then there is solid cache, solid queue, solid cable. It all started looking very solid. Just to give you an idea for why we decided to go down this path, one thing you need to know is that SQLite is an embedded database, and that means that you don't need an extra service. You don't need to run a SQLite server. You don't even need to install an SQLite database separately, because it's all compiled into a gem. You just install a gem and you have a database. You can even get rid of Redis and use SQLite. So one of the benefits is that there is virtually zero latency between your Race app and your database, because it lives inside the same process. There is no separate server. There is no inter-process communication. It has access to the same memory. It lives in the same place. If you read SQLite's doc, they even say that you shouldn't worry about N+1s because, there is no overhead, and N+1s allows SQLite to hit cache way more often. So for us, this meant less time spent on optimizations. And our application, the vast majority of our queries in our application are reads. And if you use one of those new SSD drives, SQLite is extremely fast when it comes to reads. It made our end-to-end testing way easier. So we run a mobile application using React Native, and testing those mobile applications end-to-end is a little bit more difficult than with the web apps. We run our end-to-end tests on a CI, which runs on macOS, spins up an iOS simulator, and it's kind of hard to set up your backend inside that test. So we run a single persistent end-to-end test, and we just create a new database for each test run. Because, database is just a file. So at the start of each test run, we just copy this file, and we have a new database. You don't need to start a new server for the new database, right? It's very easy. Bundle turned out to be just enough for us, because now we didn't need a separate Redis service. We didn't need a separate Postgres service. We didn't need as soon as we run bundle, we have everything we need. And don't get me wrong, I think containers are great, but there is some overhead. You need to figure out, where do you use Docker Hub for your images? There's a few things we need to figure out, a few things we need to maintain, and we just decided that we don't need it anymore. And this also means that we only need to run on a single server. Bundle is all we need. So our deployments became extremely easy, and if we have a very easy deployment, then maybe we can self-host it very easily. Maybe we don't need Heroku or Render or anything like that. And when it comes to those cost savings, I did this quick comparison. So based on the current pricing, if you want to run an app on 16 vCPUs, assuming you use those standard databases on Heroku or Render, it's cheaper by an order of magnitude to run it on Hetzner. Here, I'm assuming you use Hatchbox. So we use Hatchbox, which is almost like Heroku for your own VPS. They manage your security updates, firewall, environment variables, deploys, GitHub webhooks, the team access, cron job scripts, SSH keys, everything that Heroku does, but it costs just $10 per month at a flat price, and that's it. And if you want to scale vertically, you can go up to 48 vCPUs on Hetzner, and it's still an order of magnitude cheaper than Heroku. It was actually a bit even cheaper, but Hetzner increased pricing a little bit recently. So how did it work out? When I did initially, it was in January last year. I was the only one working on the migration. I completed it completely end-to-end in 3 days. Nowadays, we could probably do it way faster with AI. And the results are, well, our request completes around 50% faster. So I don't really know how much of that can be attributed to SQLite, because we also moved from render to Hetzner, but our requests are 50% faster, and we paid an order of magnitude less, and we don't spend nearly as much time on optimization or infrastructure. Some idea of the scale. So it wasn't a huge database. It weighted less than 2 gigabytes, and the largest table had less than 3 million rows. It has grown a little bit since then, but it's not massive. So yeah, our infrastructure cost dropped by an order of magnitude. We use Lightstream for streaming backups. So we stream it streams every change to our database to R2, but you can use any compatible S3 compatible storage, and it gives us free point-in-time recovery. So we got features that are similar to those, complex managed Postgres services that are usually pretty expensive. We can move back to any point in time in the configure period. It helps a lot with debugging. And we don't have dependency on a single platform. So last year in October, you probably remember that AWS was down for a while, and well, everyone was down, but not us. We weren't down. And even if Hetzner would go down for some reason, well, everything we have our backups streamed every second to Cloudflare. Bundle is all we need, so we can just boot up a new, say, DigitalOcean server, run bundle, replicate from Cloudflare to this new box, and within like a few minutes, we're back up. So in the end, the DevOps overhead is significantly reduced. I honestly think it's even easier to manage it than it was on render, which was already very easy. And that gives us more time to focus on features, less on the infrastructure optimizations. Again, we are a small startup. We need to optimize for those things. So our goal with the migration was we didn't want to do this like big bang cutover. We don't want to do this scary migration in one go. We wanted to have a few incremental steps that can be easily tested and reversed. So our approach was to prepare the app while still on Postgres, migrate those, well, our schema types to ensure everything will work. We don't have anything that SQLite couldn't handle, and that everything is testable at every step. And only then we wanted to switch our database adapter, migrate data, and run tests, see what fails, what doesn't. So the first issue was handling unsupported types on Postgres. So Postgres has a lot of types that SQLite doesn't, like inet, UIDs, interval, RIs. And SQLite is kind of weird when it comes to typing. So how do we store those Postgres-specific types in SQLite's very basic types without breaking anything? So if you think about it, whenever you save anything to arrays, run an inquiry, arrays needs to serialize Ruby objects into SQL, into a string, and then when you retrieve data from the database, it needs to deserialize it into Ruby objects. So we can just override how it works. We can define custom types with active record types, which tell it how to do the serialization, deserialization, and that way your business logic doesn't need to be aware of any of those changes. As an example, say you want to migrate inet, so inet column in Postgres, which maps to IP address object in Ruby. You just need to tell it how to serialize it into a string. I mean, you can store IP addresses as a string as well, so let's use that. You just need to tell it how to serialize into a string, and then how to deserialize value back into the Ruby object. You need to wire it up in the model. You can also register it globally and just use that. Then you just need to migrate those columns to strings. Postgres already knows how to do that. We also defined reverse migration, so we could revert if we needed. And, well, that's it. Arrays were a little bit more trickier to handle. So Postgres has array columns, which are pretty nice because they allow you to query for specific values in those arrays. But if we were to serialize arrays into strings, we would lose query capabilities. But, well, SQLite has native support for JSON, and an array is a valid JSON. So we just use that. And I won't bore you with the details on how to do the migration. I extracted it into this very small gem. It has like migration generator and those types implemented there. And yeah, then there's also the solid stack. There has been a lot said about it in the past, so I won't go into detail here. But with this, you can basically drop Redis, and each of those gems uses its own separate SQLite database. So again, you can test independently on stagings while the main application is still on Postgres, see if it works for you. Another challenge we ran into were database constraints. So we used custom check constraints a lot, and Postgres' syntax is slightly different than SQLite's. We didn't do anything special here. We just dropped those constraints before the data migration. We asked ChatGPT to rewrite syntax to SQLite and added them after the migration. So then we actually ran the data migration with the types migrated, with the constraints dropped. We didn't have anything that SQLite couldn't handle. We pointed the database YAM to a new SQLite file. We created a new database, and we've run this open source script that converts data. And then we've run our test suite to see if anything fails. And a few things failed, but before I go into that, I want to step on the extensions. So SQLite's core is very light, it's very small, but there's a ton of extensions that can, well, make it handle a lot of things. In particular, there is this gem called SQLin, which bundles a lot of useful C extensions, things like graphic functions and way to define custom SQL functions, like IP addresses, ROIs, regexes, a lot of those things. In the current version of Rails, all you need to do to use it is to just add a gem to your gem file, then point, and then release extensions. And after you do that, well, your extensions are already dynamically loaded. You don't need to install anything externally. So the first issue we ran into was case-insensitive search. To our surprise, SQLite has no such thing as I-like. It has like, which is case-insensitive by default, but only for ASCII. And if you wonder why, the reason is because to do case translation for full Unicode, you need to include translation table. And SQLite is so small that this translation table would double its size, so they don't include it by default. But, well, SQLin provides a gem that provides those functions. You can even alias them to override those built-in functions. You can even do something cooler. We actually use something called collate no case. So if you have columns that you always want to treat as case insensitive when it comes to searching, comparing, you can specify a custom collation function. Collation is almost like a comparison function. So you can tell it that whenever you search for, you compare this column to other columns, just ignore the case. Or you can create a virtual column. Here we are just connecting two columns to create like full name and lowercase it. With that, you can index this virtual column. This is like a virtual start column, which you can index, which makes it a little bit faster. And then if you search for a column which is marked with collate no case, you don't need to care about case insensitivity. Or with those start columns, you can just use like, as you would normally do, or you can use glob, which is SQLite's alternative, which uses syntax similar to the Unix file system. So after migrating data, we found out that arrays, we migrated those array columns to JSON, but SQLite doesn't have functions to query arrays, so some of our queries started failing. Probably this solution will be to install an array extension. I'm not sure why we didn't do that. Instead, we went with SQLite's JSON functions. And again, Steven has a great article on how to abstract that. This is also included in the gem I mentioned before. And yeah, another cool thing that that is enabled by SQLite. So SQLite is embedded, which means it runs inside your Ruby process, which means that it can also run your Ruby code if you want to. So you could, if you wanted to, define custom SQL functions or aggregates that use Ruby code. Here's a very simple example. So I'm creating a database function that uses Ruby. It uses all of the active support, all of the cool stuff in Rails. And you can just query using your function that was defined in Ruby. And you can do the same with aggregates. You can create an aggregate in Ruby, and then you can just call it from SQL. One difference we found was that nulls are treated differently in SQLite. So in Postgres, nulls are sort of treated as the highest possible value, in SQLite as the lowest possible value. If it can break some of the orderings. If you want to override it, you can use nulls last or first. As far as I know, the only way to do it cleanly is to drop to arrow, unfortunately. Yeah. So the big trade-off we have to live with now is that, in Postgres has MVCC, which means that multiple writers oftentimes can proceed at the same time as long as they're not touching the same row. In SQLite with the wall mode, you can have multiple readers concurrently, but you can only have one writer at the same time, so what does it mean? In Rails, in the new version of Rails, when you use SQLite, it uses begin immediate transaction for transactions, which uses the reserved lock, which effectively action commits or rollbacks, which is actually fine for most of the Rails updates, because in SQLite, if you use SD, they're extremely fast. But if you have a longer my transaction, like say you're doing something like that, you're opening a transaction, you're calling an update, and then calling external service. I mean, we probably shouldn't be doing that inside the transaction, but if you were to do something like that, it would block. Well, in Postgres, it would mostly work, probably, but in SQLite, it would log your entire database for writes until this call finishes. Here, the solution is simple: just don't call external services in the transaction. And another thing you could do, so let's say you have a model that's written to a lot. You could create a separate database just for this model. It's very easy in Rails. You just say that a specific model uses a different database. You just need to add it to the database YAML. You have to tell it where to store migration paths and when the database is stored. And then you can have multiple databases living in parallel, and each of them can be written to in parallel at the same time, and you can even do some queries. So yeah, another issue would be if we were to do any long data migration transactions, because migrations use transactions by default. So if you do any intensive computations inside migrations, that would lock your database for Rails for the duration of the transaction. Well, it's not SQLite's only problem. You probably shouldn't be doing large data migration inside transactions. Oftentimes, you may get by for like small updates to just drop to raw SQL, because it may just be fast enough. You can disable transactions inside migrations. But really, you should probably use something like Shopify's maintenance task, or do it in small chunks instead of one big transaction or something like that. One seemingly small but annoying thing were foreign key errors. So in Postgres, if you break a foreign key, you get this very clear error. You see that the specific constraint was broken for a specific record. In SQLite, errors are slightly less helpful. And the only solution we found so far is to replicate your database somewhere, disable foreign keys for a while, execute query that would break the foreign key, and then run a foreign key check, which will tell you which foreign keys were broken, which is kind of annoying, but doesn't happen that often. So the biggest limitation with SQLite is that you are limited to a single node. SQLite database is just a file on the disk. There is no server, so you can't connect to your database from a different node. Risk can be scaled with read replicas using something like Lightstream, but writes are still limited to one node. So how do you scale? The easiest way to scale is to go vertical, because, well, modern servers are pretty powerful, and SQLite is incredibly efficient. So even on the same server, it can work way better than another database. So you can get a lot of performance from a single large instance. And well, so we're currently running on Hetzner on 16 vCPUs, but you can go up to 48 vCPUs on Hetzner with 200 gigabytes of RAM, which is quite a lot. And there are even bare metal options with 256 vCPUs, so you can go pretty far vertically. Or you can do replication. So there are tools like Lightstream or LightFS. On RaceWork, they announced Beamer some time ago, though as far as I know, it's not yet available. There is libSQL, which is fork of SQLite, which added embedded replicas. They even have a Ruby gem, so it handles replication between nodes. It forward writes to the specific node. It makes sure that you read on your own write and such. There is Turso, which is SQLite's rewrite into Rust. It's still in beta, but it's fully SQLite compatible and adds MVCC for concurrent writes. So in the future, that will probably be a better solution. So when it comes to backups, we use Lightstream. Lightstream continuously streams every change to, in our case, to Cloudflare 2, which is very cheap. If your database is below a few gigabytes, Cloudflare's free tier will probably cover it. And it gives you point-in-time recovery. You can move back to any second within the specific period. They now, in the new version of Lightstream, they made it way faster, and they even allow you to run queries against your backups. So, like, you can have we have an AI bot that has access to our staging's replica on Cloudflare, and can run queries. You can only do reads because this is a backup against without having to replicate the whole database, and it helps us debug issues on staging. And as another backup strategy, we also do full database snapshots, which is very simple. You just basically need to run these 3 lines of code in a cron. You execute a backup command in SQLite, which creates a backup file. You gzip it, and you just move it to your S3 compatible backend. That's it. So, well, that's it. The conclusion, I don't want the takeaway to be that Postgres is bad or that every app should migrate, but I think that if you're fine with some trade-offs, especially if you have like a medium-sized app, if you are constrained by budget, but by team velocity, by deadlines, SQLite may be a really good fit for your app. I mean, Postgres is still great. Use Postgres when you need Postgres. Just don't do it because you think that serious app need to use Postgres. And if you're thinking if this kind of migration was really worth the cost, so for us, yes, even if you consider just the developer's cost, well, the migration paid it back itself in like a month or 2. And with this presentation with AIs today, you would probably be able to do it way, way faster, so it will be even cheaper. For us, well, we were driven by simplicity, cost, and team constraints, and our app is way faster. We migrated in January last year. Until now, we were very happy with the results. The app is blazing fast. We don't need to worry about it much. Overhead of self-hosting it is negligible. So yeah, that's it. Thanks.